As I was getting ready for this, I got a call from Kevin Ma from the St. Albert Gazette. He's a intrepid reporter who reports on environmental issues for the Gazette. And so he asked me what I was going to say, and I said, well, I was going to talk about why I thought net zero energy was ready for prime time. And and I was going to talk about what was happening in other jurisdictions, the advances that we'd made in the last little while. And he says, well, haven't you said all that stuff before? And I had to sort of think about that a bit. In a way, yeah, but in a way, there has been some good stuff going on, and that's when I started thinking about this as kind of a report to the shareholders, and it's sort of like this, like this really is a community effort. It started with the Riverdale project with Gordon and Andy, who are here tonight, and many other volunteers. It includes our customers without whom we could not have learned a fraction of what we did. They're the people who've taken their mortgage money and invested it in the wherewithal for us to be able to build these houses. We could not get anywhere without them. And our first effort was kind of a science project. We didn't know what we were doing, and we spent a lot too much money. The subsequent ones, these were real budgets, real families, real mortgages. We had to make it work, and it really provided some discipline that made us learn a lot faster. So really they're a huge chunk of the community. The government agencies we worked with, CMHC, Amerongen, the City of Edmonton's been a huge supporter. These things not only have helped us with expertise, but also given us some credibility that helps us expand in the passive house community, the energy consultants, renewable energy specialists, CISA hugely, and this audience. I mean, I'm a hopeless optimist, and I have all kinds of fuzzy, goofy ideas, but the prospect of talking to this audience, these smart, critical people, really makes me kind of look in the mirror, think things through more carefully, and try and get it together to really know what I'm talking about. So I want to thank you for that as well. So anyway, just without further ado, so as Rob said, we've built. We're actually over our minimum Energuide rating is actually around 82. We still will build houses like that if people are utterly uninterested in building the house we would like, which would be about Energuide 86, and we've done about 50 of them now. They're getting to be more common than the Energuide 82 houses, and as we started our net zero journey in 2007 with the Riverdale project, which was built under the CMHC Equilibrium Initiative. That project brought a number of other projects kind of sequentially, one at a time, 1 year sort of per project, and it allowed us to learn at a manageable pace and try new things, and finally kind of refine what we think is a best practice approach that should be good for quite a while. And it's one of the things that makes me confident that net zero really is ready for prime time. So right now we're working on 4 more. 3 of them are nearing completion, should be done in a month or so, next couple of months at the most. And 2 of these are on the Eco Solar Home Tour. One of them is being built under the Amerongen R2000 Net Zero Energy Pilot Program, and the owners, Dietmar Canopol and Roberta Franchuk, are here tonight, and I want to especially thank them for letting us do that on this project. Anyway, so just to sort of zoom out to the rest of the world, I've been involved with the Net Zero Energy Home Coalition for quite a while. It was started actually back in 2004 here in Alberta, and has been a booster and an information source for net zero energy for a while. In the last little while, it was always intended to be North America wide, but in the last little while, it's moved over to almost entirely to the U.S. I mean, what happened was that the Canadian Home Builders Association started a Net Zero Energy Council, which took most of the funding, and so now this is mostly an American organization. And I was just at the summit in Boston a few weeks ago, and there's a fair bit of pretty cool stuff going on in the U.S. that I'm going to talk about a little bit. But there's a lot of net zero energy activity. There are a number of small builders who are doing exclusively net zero energy houses in the Northeast and making a go of it. Some of the great big mass home builders that build 10,000 houses a year have now got net zero energy offerings, and the U.S. DOE, the Department of Energy, has gotten into it, and in a pretty serious way, in an advocacy and encouragement and training, and I'll talk about them in a bit. But California has committed to net zero energy in all new residential construction by 2020, 5 years from now, and including and by 2030 for commercial buildings, and they're aiming at a retrofit program that will build that will start to take existing buildings to net zero energy, and they've been very proactive in doing this, and it's been remarkable to me, and the sort of kind of home of the brave, land of the free, that they've taken such an apparently intrusive approach to this. It's very encouraging. But California is actually seeing the effects of climate change worse than anybody else. They've also got it easier than anybody else, particularly in the solar department and the heating department. But I think it's still really encouraging. I mean, everything, a large number of trends that we see in North America start in places like California, and it's very hopeful. So the other place that's a real hotbed is Massachusetts and the Northeast in the U.S. Massachusetts has a very active program encouraging net zero energy buildings. And it was kind of funny in this session. I ended up chairing this or moderating this policy and program session, and I, who know absolutely nothing about policy or programs, was kind of anyway to see these representatives from California and Massachusetts kind of having fisticuffs over who had the best program. I just that was encouraging in itself. But the utilities down there are getting quite active as well. They're seeing conservation as an alternative to building more generating capacity, and looking to the day when they're actually not in the business of really selling energy so much as managing the grid and keeping it reliable, more like an internet provider where the content comes from somebody else, a lot of it from renewables, and they make their money on a monthly fee. And as such, they've got lots of programs that they put real money into that have incentives and encourage people to kind of do the right thing. Well, one place that was really remarkable to me was the city of Cambridge, Massachusetts. They've committed to carbon neutrality for the entire city. They do have some advantages, and that includes transportation. They're a relatively small city, about 100,000 people. It's a fairly compact city, and they've got a highly educated population. It's a city full of scientists, basically, who totally get the predicament. And they've got terrific support from their state government. So they've mapped out a step-by-step, sector-by-sector, transportation, buildings, commercial, institutional, everything approach. They started with an energy audit of the entire city to establish benchmarks, and then they've developed reduction programs across all of the sectors, and an action plan. And the work that they've done has been I think for other, that it's basically a gift to the world in terms of the policy work that they've done. We'll be able to take that kind of material and plug into it really. And they're, it's for them it's about greenhouse gas emissions. They've got terrific buy-in at the municipal level and from big partners. So their map looks something like this. They expect to reach 70% of carbon neutrality by 2040. Watching this as an Albertan, I had a complex mix of emotions. One was hope that somebody's finally doing something somewhere, an admiration for the leadership, and then envy that it's happening there and not here, and then a little bit of shame that we really haven't got started. Did you know that Alberta is the only jurisdiction in North America that has no incentive or encouragement programs for retrofitting houses? Yeah. It's hard to imagine. I mean, one of the bright spots is here in Edmonton. The new energy transition strategy looks really good. It's hanging in the balance at City Council right now. I think that it's really important that we support the people at the city who have developed it and brought it forward. I mean, if you can get out to that City Council meeting, and I don't know the date of it, write letters to the paper, write letters to your councillor. It's really critical that our voices are heard in the right direction. Otherwise, we could be waiting a long time. It'll be helpful, I think, if the city acts. There's a better chance of the province moving. It's really important. So the U.S. Department of Energy has a branch that used to administer the Energy Star label, which is similar to our Interguide rating, not quite the same, but it's basically a package, sort of upgrades to houses, and they also do labeling of equipment and that sort of thing. So they've actually taken this Energy Star program and turned it into something they call Zero Energy Ready. And they opted for a slightly different term because they're worried about liability, and you can build a net zero energy house, but if the people living in it aren't net zero energy people, there's a good chance it won't perform that way. So they sort of took this safer and somewhat more inclusive role, because it also includes houses that are built to a certain standard and have demonstrated that if you were to put renewables on them, that they could be net zero. And so this is a big deal, I think, when a big player like this gets into the net zero space, and the builders need training. They need to pass a course that all the buildings are rated, inspected, and so you've got basically Uncle Sam's stamp of approval that you're getting what you paid for, and they realize, and that Sam Rashkin, the chief architect at the DOE, who's really the driver for this stuff, understands that builders can't sell these things unless people want to buy them, and so he's done a lot of work kind of establishing a value proposition for these houses. And it's similar to the work that was done in Canada for the R2000 program. There's no doubt that these houses are more comfortable, they're healthier, they're cheaper to operate, they're just plain better houses. Like and it's time that they be sold it that way. And it's frustrating as all get out that like the R2000 program, we can't actually sell this stuff on the basis that to me, it's real value. The fact that it's something we have to do to keep the planet habitable, the established wisdom seems to be that you can't talk about this stuff. You can't sell it on the basis of being better for the environment or saving the planet. You've got to sell it on these kind of side benefits and hope for the best. I really dearly hope that'll change. But so there are also in the U.S. a number of commercial buildings that are net zero energy, and not very many for the size of the country, but the biggest is probably the National Renewable Energy Lab. It's kind of appropriate, like who else should build net zero? That was built, I think, in 2010, and they were able to do it for roughly the cost of they were given a budget that had no extra money in it, and they were able to build a net zero energy building within that budget. Now, another one that you may know about is the Bullitt Center in Seattle. This is a LEED building, or a LEED Platinum Living Building Challenge certified building. It's net zero. You can kind of see what happens when you try to go with a multi-story building and get to be net zero. You run out of roof area pretty fast because the process loads in the building, the lighting, and even the cooling and heating go up, but the roof area doesn't unless you can do something like this. Then another interesting building that we saw in Massachusetts was the Department of Fisheries and Wildlife, and this is in keeping with the Massachusetts state commitment to actually not only encourage this stuff, but to put their money where their mouth is. And this building also is a very high quality building, beautiful, daylight filled, very comfortable, net zero energy. I'm not sure, I think it was 2013 it was finished. They've got a year of data. It's actually net zero, and a great example for the rest of it. And then right here in Edmonton, and I'm not going to talk about this and just sort of sneak preview, we've got our own net zero energy commercial building. So, if we can do it at scale, we can sure do it. We can sure do it on houses. So back here in Canada, the CHBA has established what they call a Net Zero Energy Council, and their goal is to bring resources to builders so that they can start to do this. They're more cost effectively. That involves training and information sharing. They're also trying to help to build the market. I mean, everywhere we turn, really, we've got the same problem. We know how to do this stuff now. It's not a technical problem anymore. It's a marketing problem. We need to convince people to act in their own interest. I don't know, you say something like, we need to build these houses like this, or we're all going to end up fighting over scraps of food in the desert or something. I don't know what it takes, but we do need to work on that marketing piece that will start to get people acting in the interests of their kids and grandchildren. Anyway, the other thing that Enercan is doing, or that the CHBA is doing, is working quite closely with Enercan to develop a new net zero energy label based on the new EnerGuide rating system. The rating system is undergoing a change, and we're going to see this come out end of this year, early 2016. So what they've done, nobody seemed to understand the old EnerGuide rating system, where it wasn't a straight line, it was logarithmic, and it took quite a bit of difference to change a house from EnerGuide 86 to 88, because it wasn't a straight line, and also it was kind of counterintuitive that net zero would be 100 and the worst possible house you could build would be 0. So they flipped that around and made it a consumption-based rating. So your score is basically going to be how many gigajoules a year you use. If you have a net zero energy house, it's going to be a 0 gigajoule house. And they'll also turn that into, they've done a lot of thinking about the label, and there's all kinds of other information on it. This is just a sort of snapshot of part of it. But it will be much easier to understand, and it will be the foundation for the net zero energy label that you'll be able to get along with your new EnerGuide rating. And it's got a number of benefits. It's very similar to the appliance and car ratings. Gives you a reference point to an average house. You can express improvements in just percentages. That didn't work when it was logarithmic. And it also, the old EnerGuide rating system was different depending on the size of the house, where this is just going to be straight consumption. If you've got a smaller house, you're going to get a better EnerGuide rating, and that, I think, is as it should be. And but it will not look at the energy source in any way. It's not going to compare natural gas to electricity or coal. I think that or coal-fired electricity or natural gas or heating oil. So the Dietmar and Roberta's house that we're building is being built in another national program run by Amerongen, and all of the houses will have to meet the old R2000 or the new R2000 standard, which is now EnerGuide 86 in the old scale. There are about, I think, 13 across the country. Dietmar and Roberta's is going to be the first one finished. And the idea is that no more science projects. This is like road ready, off the shelf solutions. It's going to drive this new EnerGuide rating system, the EnerGuide or the Net Zero Ready label that they're hoping to come out of this would be at least an EnerGuide 86 on the building without renewables, and then a demonstration that there's enough capacity in the roof to install enough renewables to get you there. Yeah, so this is a rough look at Dietmar and Roberta's house. And again, the house will be on the tour, so you'll be able to have a better look at it on May 30th. It's about 2,250 square feet with a finished basement. It's getting close to complete. We need to do the finish coat of stucco and obviously install the PV. The house is custom designed to their lot. It's a kind of a funny shaped lot. There's a bunch of trees across the street, so there is some shading. And we took down a great big elm tree that we've actually sawn up and made into the railing and stairs and a few other things in the house that we're pretty proud of. So you'll be able to see that at that time. So now I'm going to sort of go to a little more kind of territory that we've gone over before, but I think it's important for the people who aren't here to kind of go through the basics. Like we've figured out how to do this in a really straightforward step-by-step manner that's not that much different from designing an ordinary house. It's just kind of one more constraint, and if you attack it in the right order, it's relatively easy. And we found this out the hard way. We did it a few times and then noticed that you don't design the PV system first. And I'm just going to run you through these steps and a few of the things that we've noticed along the way, and it really yeah, and it doesn't need a big charrette. It really, I think, is ready for anybody working anywhere. And I think the fact that we now have, we counted 34, 35 net zero energy dwellings in Edmonton now, or in the Edmonton area, is sort of a testament to the fact that we know how to do this now. We can do it. So the first thing, obviously, is to evaluate the site, look at the potential shading, look at the amenities for designing the house, and I'm always looking for passive solar because that's the cheapest, easiest way to get to net zero. And then the preliminary design would happen with that in mind. Keeping it simple and compact, and thinking about where the PV is going to go. It helps a lot to keep the living spaces on the south side if that works out. It's not critical anymore, but the sort of case in point is our real. I mean, this is our net zero home run. That was our third house. It's a house in Belgravia that over the last 3 or 4 years, it's produced close to 10,000 kilowatt hours a year of electricity and used about 5,600. Now, part of that would be the owner, who is very conserving, and I often kind of joke that he probably showers at the Kinsman, but even so, with a over 4,000 kilowatt hour surplus, family of 4 could live in here comfortably without any sacrifices whatsoever. And the main reason this house is so successful is that it's a perfect solar site. So not only is the PV system producing very, very well, but it's getting over 50% of its annual space heat needs through the south-facing windows. And unfortunately, when we figured out that formula, we thought, okay, now we got it. But looking around, there isn't one site in 20 in Edmonton that would be anything close to that good. So we obviously needed we needed a plan B, or it wasn't going to go anywhere. So just going along in the steps, I mean, thinking about the roof shape. When we first started out and PV was costing $6 or $7 a kilowatt or per installed peak watt, we were putting it at the maximum angle to get every little bit of juice we could out of that and restricting the area. And now that it's come down to the 250 to 350 range, we want to get as much area as we can and not worry so much about whether we're getting maximum production, because it's overall so much cheaper. So we're actually shaping roofs almost exactly the opposite to what we did. And the other thing is that now we're finding that we can get to net zero on lots that face east and west, and Landmark's doing this on a number of them, basically. And we'll get to why you can do that now and you couldn't do it before in a sec. So after you got a rough idea of the shape of the house, the next most important thing to me is energy modeling. And I've said this so many times. I just want if you don't start with a good energy model, you'll never get there. And I was in Manitoba and in Winnipeg before Christmas, giving a couple of talks, and I had in those sessions, I had 3 separate families come up to me afterwards asking for advice on their houses that they had already started. And one of them was a mechanical engineer, and he wanted advice on air tightness because he'd heard how important air tightness was. But he built this goofy wall system. It was 2x8 with all kinds of wood in it, thermal bridging out the yin-yang, and he was committed. He couldn't do anything about it, but he wanted to make the house airtight. And I thought, good, if a mechanical engineer won't start with an energy model, what kind of hope is there for ordinary people? I sort of understand it when somebody, the one was a farm couple. They they'd read some stuff and they'd gotten along, and they could have saved themselves so much money and got so much better house if they had just done this energy model before they started, and it's critical at every scale. I mean, Dennis will talk about it on that scale. So it's critical to find out where every component, and just I'm not going to beat that horse too badly, but the way it works roughly is that you take the energy model. From it, you can find out how much energy any component of the house is. So, for example, the heat loss through the basement floor. So you would try, look at the model, see how much heat you're losing through the basement floor with one level of insulation, say R10, add another R10, so you've got R20, see how much energy you save, find out what that costs, and divide the cost by the energy saving, and then you'd get a cost to save a kilowatt hour a year, every year, year in, year out. And and then you do that for the walls, you do that for the roof, you do that for the windows, even for the mechanical system, for air tightness. And when all of those cost measures are the same, then you've got an optimal cost. Otherwise, you're in real danger of putting way too much insulation, spending too much money in one area and not enough in another. And that's what this mechanical engineer clearly didn't even start to do. And it's highly educational too. I mean, if you probably, for most people, probably need to get an energy advisor to do it for you, but you can play with it after that, and it's a good thing for builders to do at least once. And you don't have to do it for every project. After a while, you get a feel for where the levels should be, and they'll vary from builder to builder depending on your cost structure too. So it's really worth doing it, and just learning so you know why you're doing what you're doing. So nowadays there's all kinds of options for building energy efficient walls. In order of I'm not going to go through them all here. They all have their different advantages and disadvantages, and the choices will vary somewhat with your cost structure and your site, and also the target. Which of the, even your value system. We'll look at the pros and cons of a couple in just a sec. But just a caution, when you start adding more insulation to a wall, you can start to increase the risk of moisture damage within that wall, and that's one of the key and most valuable lessons of the whole passive house approach, is that as the wall gets thicker, more insulation, the sheathing gets colder. If you do have an air leak in that wall and it gets out to that cold sheathing, it's very likely to freeze and melt or freeze and accumulate, and you've got water in your walls, and nothing is ever perfect. It better be able to dry out before it does some damage. And it's possible to do analysis on this. There's lots of good material, but it's just something that whenever you think you've got a bright idea about building a better wall, to check out. So a couple of the sort of common higher R value walls, just to sort of contrast on the kind of value system. Lots of people are using high density spray foam. It's got some advantages. It can work if you're on a narrow site. Some of these skinny houses, I see it being used, and it kind of makes sense there. It doesn't do much for thermal bridging, so you get a lower effective R value than you would with the in an ordinary wall. It's pretty high embodied energy. And it's not as tight as you'd think. It still needs a fair bit of remedial work. Our favorite, and the one that we've done 50 times now, that we think is the lowest incremental cost to get R40, is the Riverdale, as the CMHC called it, the Riverdale deep wall. It follows normal construction, it's airtight. It's very little more lumber than a typical 2x6 16 on center wall, very low embodied energy, and very minimal thermal bridging. It does take more labor. The air sealing on it's a little fussier than some of the layered approaches, but we're able to get near passive house levels of air tightness with it, and it can take up big space if you're on a skinny lot. So another thing to keep in mind is, thermal bridging control. The modeling won't tell you. HOT 2000 anyway will only give you sort of a vague idea of where thermal bridging is going. It won't break it out. The passive house software is great for that, but as you get higher R values, and I'll show you a little graph in the second here, the last few remaining contact points where the insulation layer is not continuous will really eat into your energy budget. If you have a look at this slide here, if you look at a sort of a typical, the heat loss through an R15 ordinary wall, it's only maybe a quarter to a fifth of the total heat loss. As that R value gets up into the range that you want it to be for net zero energy, if you haven't done anything about the thermal bridging, it can be half. It's really worthwhile to take that in hand. So, and then air tightness, by far the cheapest energy reduction you can make. It's not that hard to get to 0.6 air changes an hour these days with the other, and it has a huge side benefit, which is that most of the moisture that's likely to get into a wall is through air leakage. You can move a lot of water with household air leaking into an insulated wall. If you've stopped that by stopping all the air leakage, you've really made your wall a whole lot safer. After you've done all the other stuff, probably the biggest single source of heat loss left is windows, and this is a little chart that caught my interest. It just kind of shows how dramatically having windows in a wall affects the overall R value of the wall. So if you start out with a window with a U value of 30, that's flip it over, that's about R3, and you put 15% of it in an R60 wall, the effective R value of that wall drops from R60 to R17. If you get a lot better window, you can keep that reduction to R34, and it just for me anyway, it gives me a kind of a feel for how important good windows are, and I'm not saying build a windowless box. I mean, we need light just to function in a house, but just get good windows. And in my little shopping list of windows, you want low conductivity in the glass, high solar heat gain on the south, low everywhere else is fine, low conductivity frames, small profile. The skinnier the window frame, the better. The good part's the glass, and that's the only reason you're putting it in there is for the glass. If you've got a big clunky frame, you've got a hole with a low R value, and a whole bunch of it's not doing you any good. The smaller you can keep that frame, the better. That's one of the reasons we like the fiberglass windows. Low conductivity spacer bar and air tightness. There are now some triple glazed or triple weather stripped windows. We found actually a big chunk of our remaining air leakage actually can be the windows themselves. And then when you're designing the house, fewer bigger windows rather than a whole bunch of little ones, because the frames are where all the heat loss is. The glass is getting pretty good. So then HRVs I treat as part of the building envelope, and I don't know if you we do the same sort of analysis. How many kilowatt hours a year is it going to save? How much is it going to cost? What's the cost per kilowatt hour per year? It should be about the same as where we stop at the conservation level. We got all excited about Air Pahoda. That's the picture in the upper right. That's a Czech HRV that we were thought was going to solve all the HRV problems: low electrical use, high energy recovery, dealing with moisture, no defrost, and it's turned out that they still need to do some work. Philip Meese here has got the first one commissioned, and he's doing a major research study for them, gratis. Work that they should have done long before we got it here, but it's amazing. They are producing the efficiency, but they're building up frost, and we're cautiously optimistic they can solve this problem. But I wouldn't buy one until then. So.